In 3.2, I'm going to split up the lecture into two parts, and I want to focus on two of the main concepts from this section. So if you go to start the homework after watching this video, you'll only be halfway through the homework. And before I even get started on the college algebra concept, I want to kind of revisit middle school long division. So remember back in middle school when you learned how to divide before they handed you a calculator? Let's talk about that. Let's talk about those steps, and then we're going to apply them for this higher concept of dividing polynomials. So what you're going to do is you typically would compare your 6 with the 48 and be like, okay, what is 6 times 48? Or what would multiply to give me 48? And you'd be like, oh, okay, well, 8 would do that for me. So I would place an 8 above here. I'm going really slow because I want you to hear certain steps. So I say 6 times what would give me 48? I place the 8 above here. Then I multiplied. 8 times 6, which gives me 48. And then I subtract it. So I compared front numbers. I don't look at the whole problem. I placed what would go into 48 above it, and then I multiplied and I subtracted. 48 minus 48 is 0, and then I bring down the 4. And then I do it again. 6 times what would give me 4? Well, that doesn't work out. That's 0. And then you learned about the remainder being 4. You may have even taken it further with numerical numbers like this, and you put a decimal place and did that. But really, once you got the remainder of the 4, you could also say that that was 4 over what you're dividing by 6, or 2/3. So what is 484 divided by 6? You'd say, oh, that's 80 and 2/3. No big deal. Let's do a little bit harder one. And so let's take 12,642 and divide it by 4. You don't look at the 2, you don't look at the 64, you don't look at this long piece, you just look at the front. You say, okay, well, 4 will go into 12. We'll go into it 3 times. You multiply 4 times 3, which gives you 12, and subtract. It gives you 0, and then you bring down the next number of 6. Then you say 4 goes into 6 one time. 1 times 4 is 4, and then you subtract 6 minus 4, which is 2. Then you bring down the next number, 4. 4 times what would give you 24, and that would be a 6. 6 times 4 is 24. Then you subtract. Then you bring down the next number, 2. Well, 4 won't go into 2, so you place a 0 there. This is your remainder. And so then we're not going to do r and then 2. We're going to say that's 2 over what we were dividing by 4, or reducing that fraction 1/2. And that would be your final answer. So I want you to notice here, we were comparing front numbers. We were multiplying and subtracting the whole way. So when you're looking at dividing polynomials, we're going to do the same thing. So part 2, let's look at long division of polynomials. So I want to divide 6x cubed minus 19x squared plus 16x minus 4 divided by x minus 2. When we're working through this, a couple of key things. One, we want to make sure this is in standard form of decreasing exponents, cubed, squared, first power, constant. And we're only going to compare front numbers when we're doing this. So I want to compare x and 6x cubed. Negative 2 is just going to go along for the ride. We're not going to complicate things and think, okay, well, how 2 is going to play into that. We're just going to look at the x and the 6x cubed. So I say x times what would give me 6x cubed? If need be, do a little scratch work along the way and say 6x cubed divided by x. And I'll do scratch work along the way on this first example, but then I'll just work it without on the rest. So if I reduce that, that gives me a 6x squared. So x times what would give me 6x cubed, and that'd be a 6x squared. And I place it above the squared term. Then I multiply 6x squared times everything out front. So if you need to do a little scratch work along the way, you can kind of do this out to the side here. So it gives me 6x cubed minus 12x squared. And I write that here, 6x cubed minus 12x squared. So just like on the previous page, I multiplied. Now I'm going to subtract. So I'm going to subtract this whole thing. Now be careful with subtracting. We saw on the first page, 48 minus 48, 12 minus 12. That all worked out really nice. But now I'm working with subtracting a large grouping here. So what I want to do is I want to multiply through by a -1 or change all the signs to make sure I don't mess it up. I think you'll get that this cancels, but I don't want you to make up this sign. Because if you mess up a sign, it dominoes out of control for the rest of the problem. So I change all the signs. So 6 and -6 cancel. -19 and +12 give me -7x squared. Then bring down the next term. And then compare again. X times what would give you negative 7x squared, and that would be a negative 7x. But again, you could do scratch work. Negative 7x squared divided by x gives you negative 7x. Then you're going to multiply. So again, if you need to do scratch work, negative 7x times x minus 2. Distribute. You get negative 7x squared plus 14x. And you place that underneath here. Don't try to do it in your head. You are very smart. You're taking a college level math class. You are a smart individual. But take precautions. Be very detailed with your work. Because now when I subtract this, I want to change all my signs. And that's where the small mistakes happen. Negative 7, positive 7 cancel. 16 and negative 4 give me 2x. And I bring down the next term, minus 4. X times what would give me 2x? And that would be a positive 2. So I'm going to multiply. 2 times x minus 2 gives me 2x minus 4. I want to subtract this whole thing. So change all the signs. You can see that 2 and negative 2 cancel. Negative 4 and 4 cancel, so it gives me 0. Now this is my remainder. There's no need for me to write a remainder of 0, so this would be my answer. Now the good thing is when you're doing division, the opposite is multiplication. You could come down here and do x minus 2 times 6x squared minus 7x plus 2. You could distribute that whole thing out and it would give you back what you're trying to divide. So just be careful as you go. Follow my processes. I've been teaching this for many years, many semesters, and hopefully following these small steps cause you not to make a small mistake that dominoes out of control in the problem. The key with this one is you really can't use your calculator for it. You could use it for your simple of combining the 16 and negative 14, especially if you struggle with negatives. But other than that, you're going to have to work this out by hand. Go slow, show your work. I expect to see all this work on your exam. Scratch work, yeah, I really don't have to see this little pieces, but if you need that to help you figure out these pieces, by all means do this. Do it over to the side so you don't get it confused with your other work. Now let's do another one. Say I want to do x plus 3, and I want to divide 2x squared plus 10x plus 12 divided by x plus 3. Again, we're going to follow the same process. We're going to divide, so we're going to compare. Compare x and 2x squared. X times what would give me 2x squared, and that would be a 2x. Again, do your scratch work over here if you need to. Then multiply. 2x times x would give you 2x squared. 2x times 3 gives you a positive 6x. I want to subtract this whole thing. So I'm going to change all the signs. 2 and negative 2 cancel. 10 and negative 6 give me a 4x and bring down the 12. I also place this number above the 10x. It gives me a placeholder to go, okay, I only got to do this one more time and I'm going to be done. X times what would give me a 4x? And that would be a positive 4. So I'm going to put plus 4. Then we'll multiply. 4 times x is 4x. 4 times 3 is positive 12. I want to subtract this whole thing. So I want to change all my signs. So 4 and negative 4 cancel. 12 and negative 12 is 0. So I have a remainder of 0. So this is my final answer. Now the remainder is not always 0. But in order to get our feet wet and figure out what we're doing, I wanted to make sure I was doing something that worked out really nicely to get us going. So let's work another one. And I want to give you different formats. So this says 5x squared minus 17x minus 12 divided by x minus 4. Okay, so I want to set it up. So my x minus 4 is going to go out here, divided by 5x squared minus 17x minus 12. So I wanted to show you this format because I want to make sure that you can set it up and set it up correctly. Again, make sure that your problem is in standard form, decreasing exponents, and then we're going to compare. Compare your front numbers. X times what would give me 5x squared? That would be a 5x. Multiply. 5x times x is 5x squared. 5x times negative 4 is negative 20x. We're creating this to be the same. So if you don't get this to be the same, you picked the wrong number. So go back and check that. Then I want to subtract this whole thing. Make sure you subtract this whole thing. So I'm going to change all my signs. I like to use a different color so I can kind of see that sign changing as I went. This cancels. I'm left with 3x. Bring down the negative 12. Then we'll multiply. X times what would give me 3x? And that would be a positive 3. So 3 times x is 3x. 3 times negative 4 is negative 12, and I want to subtract this thing. So I'm going to change all the signs. 3x and negative 3x cancel. Negative 12 and 12 cancel. Again, this one worked out really nicely. So it shows me if I were factoring this 5x squared minus 17x minus 12, these would be my two factors. This is your final answer, but you can see we've got to show our work to get us there. But I just want to do this one because it was kind of in a different format, so I want to make sure we could see that. Let's do one that doesn't have a remainder of 0. Let's look at this one. So setting it up, x plus 1 is going to go out front. X squared plus 3x plus 5 is going to go underneath. Now I'm going to start comparing. X times what would give me x squared, and that would be x. Then I'm going to multiply. X times x is x squared. X times 1 is plus 1x. And I want to subtract this whole thing. So I'm going to change all the signs. So that gives me 2x, bring down the positive 5. Then I'm going to compare again. Again, I'm not comparing anything back here. I'm only comparing the front pieces here. X times what would give me 2x, and that would be a positive 2. Multiply. 2 times x is 2x. 2 times 1 is positive 2. And then subtract this whole thing. So in order to subtract, I want to change all the signs. So 2 and negative 2 cancel. 5 and negative 2 is 3. Notice I have nowhere else, nothing else to bring down. So this is my remainder. Now when I go to write my remainder, I'm going to say plus 3 divided by whatever you're dividing by, x plus 1. And whether you like the way this looks or not, this would be your final answer. So I wanted to do one where you also had to set it up, but you also got a remainder that wasn't 0. Now, not every problem is going to be nice like the previous ones, and it's not even going to be nice that it has an x in here. So let's work one that's a little bit different. Here's one, and this time instead of being x plus or minus number, it has a 3 in there. And so I'm going to set it up. 3x minus 2 divided by, I want to make sure it's written in standard form, 12x cubed plus 23x squared plus 16x minus 4. So I want to make sure it's in descending order, so standard form, and I have zeros for any of those. We're going to do an example here in a minute how we have to put zeros in for. Then I'm going to start comparing. 3x times what would give me 12x cubed, and that would be a 4x squared. Then multiply. 4x squared times 3x is 12x cubed. 4x squared times negative 2 is negative 8x squared. I want to subtract this whole thing. So I'm going to change all my signs. I did make a typo on this problem. This should have been a minus, otherwise we're going to have some funny numbers. I apologize for that typo. So now 12 and negative 12 cancels. Negative 23 and positive 8 is negative 15x squared. And then bring down the next term, so plus 16x. Now compare again. 3x times what is negative 15x squared, and that's a negative 5x. Multiply. Negative 5x times everything out front. Negative 5x times 3x is negative 15x squared. Negative 5x times negative 2 is positive 10x. I want to subtract that whole thing. So I'm going to change all the signs. So this cancels, and 16 minus 10, or 16 plus, and negative 10 is 6x. Bring down the last term, negative 4. Compare once more. 3x times what would give me 6x? That's a positive 2. Then multiply. 2 times 3x is 6x. 2 times negative 2 is negative 4. And I'm going to subtract this whole thing. So I want to change all the signs. 6x minus 6x cancel. Negative 4 and positive 4 cancel. So this did give me a 0 remainder, so this would be my final answer. I specifically wanted to do this problem because I wanted to show you with kind of some larger coefficients, but also show you when a number is not just x plus or minus a number. 2 more examples and we'll be done with long division. And again, there is a part 2 to this lecture, so when you go do your homework, you're only going to be able to do half of it. So let's set it up. We're going to do x minus 5 out front, and x cubed minus 6x squared minus 15x plus 10. They're in descending order. If you feel really good with this, I would pause the video now, work it out on your own, and then come back and hit play and see if you got it correct. So I'm gonna compare numbers. X times what would give me x cubed? That would be an x squared. Multiply. X squared times everything out front, so that gives me x cubed minus 5x squared. I want to subtract that whole thing. So just multiplying and subtracting. Change all the signs. This cancels. I'm left with negative 1x squared, because negative 6 and positive 5, and bring down the next term, minus 15x. Then compare again. X times what would give you negative 1x squared? That would be negative 1x. Multiply. X times x. Negative x times x is negative x squared. Negative x times negative 5 is positive 5x. And I'm going to subtract this whole thing. So I'm going to change all the signs. Be careful with all those negatives. Negative 1 and positive 1 cancel. Negative 15 and negative 5 is negative 20x. Bring down the next term. Then compare. X times what would give you negative 20x? That would be minus 20. Multiply. Negative 20 times x is negative 20x. Negative 20 times negative 5 is positive 100. I'm going to subtract this thing. So I want to change all my signs. This cancels, and I'm actually left with negative 90. So you don't want to just start marking out that last term. It's not always going to be a nice remainder of 0. 0 is bad if it's your bank account, but 0 as an answer is fine. Negative 90 could be the remainder. So I'm going to say minus 90 over x minus 5. I know you're very used to other math courses before your college level math of getting nice answers, not really getting numbers like this. You could get remainders of negative 90. You could get 246. I've seen remainders of like 4 and 5 digits. So just because your remainder is large, don't assume you did it wrong. As long as you're being very detailed oriented, make sure you're multiplying and subtracting as you go, you'll be on the right track. So don't let it freak you out if the remainder is really large. It's not always going to be nice at just 0. Type it in, see if you got it right. If you don't get it right, contact me. Let me help you with it. Shoot me a message, hey, I'm working on number 7. I don't think it's right. I'll look at what's there. Or even better, shoot me a picture of your scratch work and say, hey, this is what I'm doing on this. Can you see where I'm going wrong? I must be missing something. Let's do one more example to finish up this part 1. This says divide x cubed minus 1 by x minus 1. So x minus 1 is going to go out front. Then I'm going to have x cubed minus 1. So here's where those zeros come into play. You want to write them in descending order. I have an x cubed. I don't have a square, so I'm going to have to say plus 0x squared. I don't have an x, so I'm going to have to say plus 0x. I do have a minus 1. So this is what I've been talking about the whole lecture, and like make sure it's in descending order. Make sure it has zeros as placeholders, because it's going to help us to combine like terms correctly. So I'm going to compare the front numbers, x and x cubed. X times what would give me x cubed, and that would be an x squared. Also gives me a place to line these up. X squared times x is x cubed. X squared times negative 1 is negative 1x squared. I'm going to subtract this whole thing. So I want to change all the signs. X cubed and negative x cubed, that cancels. 0 and 1 gives me 1x squared. So that helped me to combine like terms correctly and be very organized. I'm going to bring down the next term. So plus 0x. Now I'm going to compare again. X times what would give me x squared, and that would be a plus x. Multiply. X times x is x squared. X times negative 1 is negative 1x, and I want to subtract this whole thing. So I'm going to change all the signs. So 1 and negative 1 cancels. 0 and 1 gives me 1x, and bring down the next term, minus 1. Then I'm going to multiply, I'm going to compare again. X times what would give me 1x? That would be a positive 1. Then we'll multiply. 1 times x is x. 1 times negative 1 is negative 1. I'm going to subtract this whole thing. So I'm going to change all the signs. X and negative x cancel. Negative 1 and positive 1 cancel to give me 0. And so this would be my final answer. But I wanted to do one specifically with zeros in it because I wanted you to see how it can help you to organize, set up your terms, give you placeholders, etc. Just like you did with long division back in middle school. You had to use zeros at some point. So I hope this helps with the first part of the lesson. If you have any questions, feel free to contact me.